Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3. We will present type of soil reinforcement. I will introduce our group member. First, Muhammad Arif Afdan bin Nur Razali, TQ24061. Second, Iman Fidaus bin Andi Nizamli, TQ24043. Third, Ahmad Fahim Hasif bin Ahmad Faruzi, TQ24065. And lastly, Muhammad Darwish bin Cik Sulaiman, TQ24046.
Soil reinforcement is an engineering method used to improve the strength and stability of soil. It is commonly applied in areas with slopes, embankments, and wet ground conditions to prevent soil movement and erosion. By using reinforcement systems such as gabion walls, geotextiles, and retaining structure, soil reinforcement helps support loads, control erosion, and ensure the safety of surrounding structures. This method is widely used in civil engineering projects to improve ground performance and durability.
Okay, so we can go through about the type of soil reinforcement. As you can see here, we have a mechanically stabilized earth wall, that is MSE. The second one we have is reinforced concrete retaining wall. The third one is we have the vegetative reinforcement, and the last one we have the gabion wall. Let's look onto the mechanically stabilized earth wall MSE first. Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Iman Firdaus. The ID metric is TQ2443. And right now, as the first presenter, I will present to you about the mechanically stabilized earth MSE wall that I found on the Israeli side. So what is MSE wall first? Let's get to know each other. MSE wall is a type of composite earth structure that used primarily for soil retention and load support, instead of relying solely on the mass of concrete structure like gravity wall or cantilever footing to hold back the soil. And MSE wall is also reinforce the soil itself to make it more stable. So the function of this wall is that this wall can soil retention and slope stabilization, can also hydraulic protection from the sea walls and dikes, and also it has a dynamic load resistant, supporting heavy vertical loads such as bridge abutments, and lastly, it's also maximizing the right-of-way of urban space optimization. So let's look onto our first main problem. That is, you can find on our MSE wall, that is the vegetation on the crest. It caused by the root damage and hydrostatic pressure that occur as our times flows by. So the vegetation crest, the root damage from the tree can cause the backfill to interfere with the reinforcement of our wall and the geogrades that hold up the wall. They can also cause the clogged drainage of the layers. The hydrostatic pressure can cause our wall to expand even further with water, as it adds unnecessary pressure behind the top panels that potentially pushing it outwards throughout the time. So another problem that we can found on our wall, as you can see, that the water drainage issue that can cause the efflorescence or staining issue. As you can see, that it has a dark stain issue that is caused by the water running down from the wall or seeping through the joints. This suggests that the surface of the wall should be diverted away. The water from the wall should be diverted away from the wall in order for us to avoid this staining. And also, we can find the efflorescence. This white chalk on the wall, as we can see, it causes by the efflorescence that has been built up throughout the time. This happens because the water saturates the concrete or backfill, and the salt dissolves inside of it. So the surface becomes stained as the water evaporates. This is a clear sign that the water is trapped inside our wall or overflowing throughout it excessively, which can eventually corrode the steel reinforcement or wash out the soil particles. And lastly, we can look onto the lack of coping. First, coping is basically a put or placed on top of final raw panels. This coping type is to lock the top panels in place and seal the joint between the soil and the wall surface. The problem is that a direct hit from the rain or water away from the flowing behind the panel can cause this flows directly from the glass swab into backfill behind the panels by exacerbating it as issues mentioned above. So first, let's look onto our solution to prevent this kind of problem. We can see that we can use the cosmetic restoration to restore up the looks of our wall. That we can use pressure washing or chemical cleanings for our stubborn efflorescence, because efflorescence is not gonna work by washing it harder. It may use also the chemical cleaning in order for it to rub away. So the second one is vegetation management. As you can see, vegetation are the main cause of our wall issue. So to prevent it from happen, we can remove the trees or large shrubs by cutting down the trees growing directly on the crest or top of the edge. Gears can clog the drain edge and push out the panel outwards. So we must cut it down first before it will grow even further. And we can also prevent it from the root barrier by removing it since it was little, or install a root barrier membrane at least 1 or 2 meters behind the wall face to force the root downward rather than the sideway into the wall structure. And secondly, we can see the surface water control. We can use this surface water control to control the water flow throughout our wall, so that our wall won't get any water staining or efflorescence, because we can use the regrade the slope to reshape the soil at the top, so the slope away from the wall or at least 1 to 1.5 meters. Currently it appears flat toward the wall, so acting as a funnel for the rain. Or we can also use the concrete dish drain. As you can see, concrete dish drain behind the coping. This captures the surface runoff from the slope and channels it to the sides of the embankment, preventing it from soaking into the reinforced soil mass. And lastly, we can check the internal drainage. Once the surface water is managed, you must ensure the water trapped inside can get out. So we must check the outlets or clear the weep holes or end joints also. And that's all for me. Thank you very much. We can move on to our next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Afnan bin Nur Razali, TQ24061. I will present about reinforced concrete retaining wall. Reinforced concrete retaining wall is a soil reinforcement structure used to support soil and maintain stability at different ground level. They are constructed using concrete and steel reinforcement to resist lateral earth pressure from the retained soil. The wall help prevent soil movement, slab failure, and erosion, especially in areas with uneven terrain or limited space. The function of the reinforced concrete retaining wall is resistant lateral earth pressure from the retained soil, prevents soil movement and slab failure, maintain ground stability at different elevation level, support infrastructure such as road, building, and embankment, help control erosion and soil collapse. The problem for reinforced concrete retaining wall is structure cracking observed on the reinforced concrete retaining wall, increased lateral earth pressure acting on the wall, inadequate drainage system leading to water accumulation behind the wall, vegetation growth contribution to additional loading and moisture infiltration. The solution for this type of wall is repair and reinforce crack on the retaining wall to restore structural integrity and prevent further deterioration. Improve the drainage system behind the wall to prevent water accumulation, reduce lateral soil pressure, and minimize hydrostatic stress. Remove and control vegetation growth at the top to prevent roof infiltration, and additional loading on the wall. Lastly, regular inspection and maintenance to monitor crack, drainage performance, and vegetation, ensuring long-term for stability.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fahimasi bin Ahmad Faruzi, and I will continue to present about vegetative reinforcement. Vegetative reinforcement is a soil stabilization method that uses plants such as grass, shrubs, or small trees to strengthen the soil structure on slopes or ground surface. The root system of the vegetation help bind soil particles together, improving slope stability and reducing soil erosion. Okay, the location of the vegetative reinforcement is at Kampung Sungai Belat, 260 Gambang, Pahang. Vegetative reinforcement functions by using plant roots to bind and strengthen the soil, which help to improve slope stability. It reduces soil erosion by slowing down rainwater runoff and protecting the soil surface. The vegetation also helps control surface water flow and minimize soil loss during heavy rainfall. At the same time, it provides an environmentally friendly solution that enhance the natural appearance of the area. The main problem in vegetative reinforcement is when plants do not grow well or die, causing the soil surface to become exposed. When vegetation coverage is sparse or uneven, rainwater can easily wash away the soil. This leads to erosion, such as small gullies forming on the slope. Poor maintenance also can make the situation worse as overgrown or dying plants cannot effectively hold the soil. To overcome these problems, suitable grass or vegetation with stronger root system should be replanted to improve soil binding. Surface drainage must be improved to control water flow and prevent excessive runoff during heavy rainfall. Regular maintenance such as trimming, watering, and replanting is important to ensure healthy vegetation growth. In addition, erosion control mats or geotextile can be used to protect the soil surface and support vegetation establishment.
Assalamualaikum. My name is Muhammad Darwish bin Cik Sulaiman. Now I will present about our study on gabion reinforcement. The gabion wall is made of wire mesh cake filled with stone. It is commonly used on slope and roadside areas. The main purpose of a gabion wall is to make the soil more stable and reduce erosion. Water can flow through the stone, so it helps to reduce water pressure. The Gabang Wall is located in Kampong Sungai Belat, Gambang, Pahang. It is built along a roadside slope with surrounding vegetation. The structure helps to support the soil at this location. The function of gabion wall is to stabilize the slope and prevent soil movement, to control soil erosion along the roadside, to retain the soil behind the wall, to allow water to drain naturally through the stone. During the observation, we identify several problems. First, vegetation is growing around the gabion wall. This may affect the durability of the structure. Second, soil and plant roots may block the drainage path. This can reduce water flow through the gabion wall. Lastly, the wire mesh may corrode over time due to long-term exposure. To solve this problem, we suggest the following solution. First, regular maintenance and inspection should be carried out. Second, excessive vegetation around the gabion wall should be removed. Third, damaged or corroded wire mesh should be replaced if needed. Lastly, proper drainage should be ensured to prevent water accumulation. In conclusion, soil reinforcement is important for improving slope stability and reducing soil erosion. Different reinforcement systems such as MSE walls, reinforcement concrete retaining wall, vegetative reinforcement, and gabion wall are used based on the site condition and engineering requirement. With the proper drainage, vegetation control, and regular maintenance, the system can work effectively and help ensure long-term safety. That's all from our group. Thank you.